Gauss's law allows us to find electric forces in situations where using Coulomb's law would be very difficult. But in order to understand Gauss's law, we must first understand a concept called the electric flux. The electric flux is the amount of electric field that pierces a surface. So if the electric field is perpendicular to the surface, so if the electric field vectors are at right angles to the surface, then the flux through the surface is defined as being equal to the strength of the electric field times the area that the electric field is piercing. In general, if the electric field is not at right angles to the surface that it is passing through, then the electric flux is defined as being the electric field times the area times the cosine of the angle, where the angle is the angle between the electric field direction and the normal, or the perpendicular, to the surface area. So the electric field and the electric flux, the relationship between those two is kind of like trying to catch raindrops in a barrel. If you imagine trying to catch raindrops in a barrel or a bucket, how do you want to hold the bucket to catch the most rain? Well, you'd want to hold the bucket so that the surface opening of the bucket is perpendicular to the direction of the rainfall. If the rainfall is coming in at a slant, you'd want to tilt your bucket, and so that the bucket opening is still perpendicular to the direction that the rain is coming. That way you catch the most raindrops. And the same is true for electric flux. You'll get the biggest flux through a surface that is perpendicular to the incoming electric field vectors, and you'll get less electric flux if there is an angle between the direction of the electric field vectors and the direction that's perpendicular to the surface that the electric field vectors are passing through. So there is a convention that is used to determine the sign of the electric flux. The electric flux is negative when the electric field points into a surface, and it is positive when the electric field points out of a surface. So for a flat surface like we saw on the previous slide, this doesn't really make much sense what's into and what's out of. This is more commonly used when you have a closed surface. So imagine that you have a ball, a closed ball. If you have electric field vectors going into the ball, then that would be negative. If the vectors are coming out, then that would be positive. So look at this picture and think about this question. A cylindrical piece of insulating material is placed in an external electric field as shown. What is the net electric flux passing through the surface of this cylinder, and what sign does it have?